species. What more do you want? And so don't try to read this. This is just a quote because guys who get PowerPoint can read this themselves. There were two boys in Philadelphia. They had severe combined immunodeficiency, SCID, boys in the bubble. They couldn't come out. They would be attacked. They didn't have immunity. And they got real tired of living that way. And so one day, the medical people said, would you like to try to take the gene that's in everybody else and put it in you so you can live like normal people? And they said yes. Okay? Now, when you put the gene in the boy that gave them immunity, you stuck on a promoter. Like I said, why put it in if it's going to be quiet? Okay, and they might have put on a marker, I can't remember. So they injected the boys, and the genes went into the bodies of the immune cells. And what happened? Did they get immune? No. Well, we don't know. They died of cancer. You turned on the leukemia genes by mistake. This is published in New England Journal of Medicine. This is our lead medical journal. Furthermore, they did a study that said, whoa, how unlucky. You turned on the wrong gene, the leukemia gene. That was more than luck. They actually calculated there was a 4-fold above luck. In other words, those leukemia genes call the promoters. They can't wait to turn on. And so the medical people, we have a moratorium on gene therapy. Gene therapy has been the biggest disappointment ever in the last 40 years of medicine. It was so much promise, but when we realized that genes are so complicated that we have a moratorium until you can put exactly where you want it, not turn on the leukemia gene. You can turn on exactly what you want. So even if you put in the wrong thing, don't turn it on. If it's a mistake, you can pull it out, or you can turn it off. The 4 conditions. We can't do one of them. And so the medical guys, we're very alarmed, and we don't do it, okay? But the plant guys, hey, well, the plant guys are plant guys, except for one problem here. Now let me get this. Here's the problem. Here's the problem. When you grow these plants and eat these plants, these doctors, Chavik from Norway, Ermakova from Russia, Putsai, Pakistani in England. Putsai's work has been questioned. Even he admits something wasn't quite right. But Ermakova, Chavik, there's tons of them now. They have shown that an animal, like a mouse, when fed GM food, the construct, the marker, the promoter, and the gene will go into the stomach cells of the rat and turn on within 2 hours of first feeding. That is one heck of a transfer. Though I warned you that these are promiscuous genes and they go out and turn in. You've constructed the gene so it can cross species. But what did you expect it to do when you go into the mouse? And it not in the mouse stomach, in the mouse stomach cells, and was on. Then in 6 hours, the stomach, the blood goes up into the lymph nodes. It's in the lymph nodes and on. So that was the mouse or the rat, maybe the rat. But they also did cultures, human tissue cultures, kidney, intestine, not human, but he puts these genetic things on the plankton and they incorporate in the cell tissue. The stuff is crossing and it's active. Even Monsanto will admit they're active. Okay? So the stuff does cross into mammalian and human cell lines. Dr. Ermakova, she was Russian and she did very interesting studies. She fed the mice GM food, and the mice she was looking at birth defects and diminished litter size, which means birth defect in utero that they never delivered. She saw a bunch of them. The industry tried to repeat it and couldn't repeat what she saw. She tried to repeat it and couldn't repeat what she saw. She tried to repeat it again and saw it again. The stuff, sometimes you see it, sometimes you don't. Sometimes you see it, sometimes you don't. In my field of science, drugs and vaccines, you will not do any study in the lab, in the animals or in humans, until you can produce the product consistently. There's a principle called GMP, it's almost like GMO, good manufacturing practice. If you cannot produce it consistently, don't bother testing, because the testing will be all over the board, which seems to be what we see. But that was perfect for the industry, because when Ermakova showed it, and they didn't, and then she didn't, and then they will use the negative data, looks safe to me, to negate her positive data. That's not how science works. You don't use negative data to refute positive data. You want to do that? I can take, all of us decide we should smoke. Some of us get cancer, some of us don't. The guys who don't, does that mean these guys don't get cancer? You don't use negative data to refute positive data, number one. Number two, you don't even try to interpret a study until the product is made consistently, okay? And the product, believe me, they can make it maybe consistent for the intended product, but all those weird things going on, those free promoters turning things on, and we don't even know how to screen for that. So that's a problem, okay? Now, the stuff is active and crossing. This is kind of a mess. I'll go through this pretty quickly. I have messed with GM products. We took a genetically modified vaccine and we tested it in HIV patients. It was for hepatitis B. But how did we do it? We produced it in the laboratory where it was contained in a biosafety lab. The mutation, the gene mutation didn't escape. We purified the protein of the modification. Remember the expressed protein. That's not GMO. That doesn't have a promoter. That's the product. We purified the product. We took it to market. We labeled it. We gave it to the people who should get it, high dose, HIV. And we only use it for HIV patients, and it's labeled. When there's a mistake, and there have been quite a few mistakes with different products, we recall it. I think it was worthwhile, the risk and benefit, but you see how it's done. Contained, labeled, marketed, used as indicated. Here we have the GM field products, growing wiley-niley. It is in the wind, it is in the soil, it is next to our elementary school kids, it's in the wastewater, it's in the workers, it's in the community. And these guys called me, and they said, can you help us? There's the dust, we're breathing the dust. And I said, oh, that's that. Isn't there any protection? They said, no, no, no. All the wives are trying to make these handkerchiefs. And they said, but the bags is not for human consumption, but they're breathing the dust. And I said, wow, I'll check this out. So I called state, Department of Labor. Said, hey, the guys are breathing uncontrolled the dust, and the bags is not for human consumption. So the guy says, well, they're not eating it, are they? Oh. And wait, this gets even stranger. I said, wait, they're breathing it. That's a heavy-duty exposure. He says, are you a doctor? He said, yes. I said, I'll call you back. Call you back, and he never did. And I called him again, and he never called me back again. So I'm used to getting stonewalled, but this kind of stuff, I mean, that has got to stop. Incidentally, those guys are not dumb. They came out first with a salivary gland tumor. And they actually said, we know we can never prove this, but for the rest of us breathing the dust, can you help us? So the Department of Labor tried to take a stand on this stuff. Now, it's in the field, and then, lo and behold, these guys tried to grow food that makes pharmaceuticals. Wow. So you grow the corn not for pharmaceuticals, but to harvest insulin, to harvest spermicides. You can make the corn or the plant do anything. Almost like we use the term plant for a factory. A plant is a plant that can make products. And then we eat the stuff. Now, do you not think GMOs are dangerous? Industry will say harm has never been shown. Well, there was one product, it's the most fascinating thing I've ever read, and it goes by the acronym TGN 1412. And this was a GM product, tested in humans first before it went to market, and it was some immunomodulator, like the one they tried to bring into Kona, which we blocked. And they give it to 10 guys. But first they gave it to dogs. The dogs did real well. And they gave 1/50th the dose to 10 people in the UK. That made front page headlines in Star Bulletin and Maui News. I've never seen a study of 10 people make front page done in the UK appear in Star Bulletin because it was the most bizarre medical things we have ever seen. Okay? Now, that was strange. I don't know if they got the mutation or just the product, or the product and the mutation. Who knows? But they quickly, Pajero is the name of the company, shut that down and don't talk about it. And there was an inquiry worldwide, thank goodness for New Zealand. The Prime Minister of New Zealand said, was that a GMO product? And they refused to answer, stonewall. And they found out it was. So she says, it was a GMO product. thank God for once you did the normal testing, and we didn't release it in fields like they tried to do in Kona, which we blocked. Okay, an immunomodulator was coming down in Kona in the algae. Okay, then what did the company say? Oh, you know all that weird stuff? Must have been a contaminant. Must have been a contaminant. That's gray area, isn't it? All those unintended spots. What are you going to do? Call that contaminant? So the German government said, contaminant or not, it was made to the correct recipe. And if it was a contaminant, it's inevitable in your product. So that company quickly shut down, never to be heard from again. There's other companies that were messing and they were shut down. Do not rain on our parade. Let us go with the food. Okay, so that was a little bit scary. Now, wait, let me get the things here. Okay, what do we propose? I always learned the precautionary principle. Before, you can take any product you want, and we're about to give it to humans, or put it in the environment. Before you do that, you have to generate data, not opinion, to show the benefit to risk of each of your products. So we do it for aspirin, we do it for flu vaccine, we do it for each product. You don't trust the company. You don't say, Merck Sharp and Dohme, right? You guys do a good job, cut loose, do whatever you want. You sure, you know, do it for Monsanto. You know, hey, you guys did a good job there. Go make whatever you want. It's for each product, okay? And how do we show the data? Now is my chance to end it. In the field of science, there are 4 areas which I've learned are so complicated, we only evaluate them empirically. We observe. We don't try to guess what's going to happen. One is the brain. If, my God, you know, when I went through surgery, you could cut that part and you could cut the bone, and we kind of figured out if I cut the bone, that thing is going to happen there, and I better not cut that. But when you mess with the brain, holy cow, you do some general stuff like don't infect the guy, but we do our best so he doesn't bleed, and we stand back and, oh, did you see what happened on that? Because the brain is very complicated. The next area complicated is the gene, the genome, and we learn this every day. The next area is environment. Even a mulch pile, you know, mulch, I was talking to Greenleaf today, that's complicated. You mess with one thing, you have no idea what you're causing. So when we get data, does that mean we can't study it? Of course not. That means we do stuff to it. That's a guy looking in binoculars, and he's looking to see what he sees. Generally, there's 2 groups, the treatment group and the control group, and that's called empirical data. He just observes, because he doesn't have the arrogance to say, this is going to happen. There's one more area that's real complicated. We have no idea what we're doing. We don't manipulate it. Deep space. We can't manipulate deep space. All we do is observe and go, oh, look at that. Look at those black holes. Look at those white dwarfs. Look at those viable planets. So we observe, and we have learned to respect things that we don't understand. Okay. Then, once we generate the risk and benefit, we compare the ratios amongst the alternatives. You want this or you want that. And then we usually compare it, we make sure we have the standard treatment, and if the benefits outweigh the risks, we go forward. We mark it on a provisional basis. We do the trials, we test them in animals, we test them in humans, phase 1, 2, 3, all the way to humans. Then we go marketing, and we label it, and we monitor post-market. And 50% of our drugs and vaccines, 50%, severe side effects are seen post-marketing. We either pull them back or we relabel them not to be used with these conditions. So post-marketing is very, very important. But post-marketing means labeling. Until this step, we always get informed consent. Like, we don't really know the risk-benefit. We get some ideas, but we don't really know until 20 years of post-marketing. So when you're about to take this, would you please sign this that you got informed consent? This is not a CYA maneuver so you don't get sued. I truly inform you. We don't know too much about this. We think the benefits outweigh the risk. Want to try? You're going to say, whoa, when I start getting sick and you stop the drug, is that good? Am I home free? Sometimes I say, well, the boys in Philadelphia, when we stopped that gene transfer, they had leukemia.